Hello everyone, I'm Garima Bajpai, your host. Today I'm going to talk about a very interesting topic, future-ready site reliability engineers. I call them frontline workforce for a reason, and we'll discover why. This session is a preview for the SRE Summit June 2024, which is happening in Canada. If you don't know me, I am the founder for the DevOps community of practice here in Canada, which has several chapters. There are several meetup groups which are engaged actively with us. So we have chapters in Ottawa, Montreal, Edmonton, Atlantic provinces. If you're around and you're interested, do join one of our chapters and let's quickly get started with this topic of the day. It's kind of interesting because a few days back, Gartner also released their hype cycle for SRE. So we'll also talk about that. So first things first, software frontline workforce, site reliability engineers. And you must be wondering what are frontline workers and why are we associating site reliability engineers to frontline workers? So frontline workers by definition are employees who provide goods or services directly to the users. Frontline jobs also tend to be shift-based with rotating teams and schedules. So probably now you could relate more towards this term. The world of software is changing, and so is the expectation from the SRE, our software frontline workforce. Our software frontline workforce is constantly tasked to minimize downtime, manage incidents, prioritize customer experience, and boost efficiency. And some other tenets of SRE, as stated by Google, is availability, ensuring the application and the software is available. Latency is another factor. Performance, efficiency. They do also have an active role to play in change management, monitoring, emergency response, and capacity planning. So let's dig deeper into how the SRE world is changing and what is the paradigm of evolution of practices in this space. So I'll start with the hype cycle of site reliability engineering 2024. This was recently released by Gartner. There are several areas of engagement. We will talk about few of them. So basically, I've divided this into two parts. These practices, which you see on the right-hand side, some of these practices are operational practices, including SLO management, log monitoring analysis, and continuous resilience automation. They also talk about new and upcoming practices around SLO management, like open SLOs. We will talk about that, AI assistants, and how they are helping site reliability engineers. So we will also talk about a few of these things. Another aspect which is highlighted is the feedback loop or optimizing delivery, including error budgets, for example, managing progressive delivery, observability-driven development, and managing AI-generated threats, etc. So we probably will touch base upon a few of them as well in this session. So first things first, recapping the journey of site reliability engineers. So I will quote a few things from the Google SRE book and the resources which are available online. SRE is what happens when you ask a software engineer to design an operations team. So do remember that. 50% of the cap of the aggregated ops work for all SREs. Like if you're working as an SRE, 50% of your time must be invested in real ops work like tickets, on-call, manual tasks, etc. But I mean, 50% of your task should be focused on how do you make SRE world more painless and toil-free, which is basically development side of it, and making it more, efficient and, looking at automation, looking at, new ways of working, emerging technology, and so on and so forth. We, as SREs, want systems to be automatic, not automated. And it's a very big statement. I think we will learn more about it in the upcoming slides, how this is being, instrumented, operates under a blameless, free postmortem culture. So obviously, the idea behind SRE is how to find the real root cause of the problem and try to kind of make the system free from those bugs, those outages by acting upon the real cause of the problem rather than blaming, the operational silos or blaming, the technical debt or any other parts of the problem. So error budget stems from an observation that 100% is wrong reliability target for basically everything. That's another, in principle view from SREs. And it's very, very important that we reflect on that. The price of reliability is the pursuit of utmost simplicity. And of course, if you think about all these things together, SRE is a different way of dealing with operational problems and operational workload, and it's a mindset shift. So obviously a lot has happened in the past. We also would like to recap from this journey what SREs typically would do in their day-to-day job. So obviously tickets that signify that human need to take an action, but not immediately. So obviously there are ticket systems and there are tickets which are kind of, dealt with by different teams. But the essential part of this is like tickets are something which needs to be acted upon in a window, time window. And alerts. Alerts signify that the human need to take an action immediately in response to something that is either happening or about to happen in order to improve the situation. And these are, the alerts are being kind of acted upon the SREs, and there is a lot of uh, room for improvement in how we deal with alerts. Logs. No one needs to look at this information, but it is recorded for diagnostic and forensic purposes. And this is a little bit of mindset shift. And this, I think, you will see in the later slides that some parts of it is changing constantly because logs are found more useful in cloud native world if we have more new and emerging technology integrated into SREs. I think we have a better possibility for visualizing these logs, digging deeper into, what they present to us, and also use them for proactive maintenance. Emergency response, reliability is a function of mean time to failure and mean time to repair. So obviously, there is a correlation between these two things, and the recovery or response time should be as fast as possible. Obviously, we all agree that 100% reliability of everything is a myth, right? So again, emergency response is about recovering the system as to the normal state as fast as possible. Change, SRE has found that roughly 70% of the outages are due to change in the live system. So obviously, probably this is an area of improvement, and also with cloud-based resources, with cloud-native technology, with a shift from monolithic to microservices-based systems, we have seen some of these parts getting more complex and some of these parts becoming more resilient. So obviously there is more work to be done in that area. So now we also talk a little bit about recapping the journey with service level objectives, SLOs, which is like the vocabulary check for SREs. So SLO is a performance target set by a service provider to ensure the desired level of quality and reliability of their service. Service level indicators is SLIs, is a measurable indicator used to evaluate the performance or quality of service. Service level agreement, which is SLA, is a formal agreement between a service provider and its customers that outline the term and conditions for delivering the service. An error budget, lastly, is the amount of error that your service can accumulate over a certain period of time before your users start being unhappy. So that was the vocabulary check for SREs. Now let's get into a little bit more what is happening today and what is in store for future. So starting from SLO management tools, if you see on the right left hand side, some of you have had experiences with these tools. So starting from Prometheus plus Grafana, it's an open source monitoring solution where you can custom build your SLO dashboards. Datadog SLOs provide monitor-based SLOs and metric-based SLOs, and it's a cloud-based deployment. Blameless is another company which has a similar tool called SLO Manager, provides many self-service options for SLO management. And there are many features associated with it. Captain is another cloud-based open source tool. Captain Matrix Operator provides automated configuration of observability tools, creation of dashboards, and alerting based on service level objectives. Coming to the new tools and new applications of SLO management tools, starting from open SLOs, it's an SLO language that is declaratively defining reliability and performance targets using a simple YML specification, and we can talk more about it in the next slide. SLO tracker is another tool that tracks SLO and burn rate, an open source tool designed to make error budgets and SLO tracking simpler. And lastly, Sloth Prometheus SLO generator tool to create and manage content for reliability tracking from logs and event data. Now, this is not an exhaustive list of tools. There are similar tools like Datadog, Blameless, from Noble Line, for example, Splunk. There are many other, New Relic. So we'll not dig deeper into like what similar tools are available, but this is like the landscape of high-level landscape of tools. And now we also see that some more progressive tools are coming up. So when you refer to the Gartner's hype cycle, they have specifically mentioned SLO management and OpenSLO as one of the contenders, right, in their hype cycle at the naive stages. So what OpenSLO does is, obviously this project is in early stages. I've also have stick the link in the slide. This essentially shifts left the service level objectives. What it means is, you know, OpenSLO is a service level objective language that declaratively defines reliability and performance target using a simple YML specification, embedding SLIs, alert policies, notifications in the code, and defining SLO in the project repositories. So why is it required? Because the volume, variety, and velocity of managing SLOs in runtimes is getting out of hand in the cloud native context. And if you shift left from a service level objective perspective, it makes us takes us to a more robust posture of applications, right from the development stages. Now, I will move on to error budgets. So error budgets, obviously, there are many attempts to kind of adopt error budgets. One of the attempts which was done by Expedia Group, and I have also sticked a link in the bottom of the slide. Adoption of error budgets and operationalizing policies and instrumenting run rates needs applying observability. An error budget is 1 minus the SLO of your service. A 99.9% SLO service has 0.1 error budget. That's how it is getting calculated. Now, in order to kind of ensure that you operationalize this, you have to instrument policies like SLO miss policy, outage policy, escalation policy, and protect your customers from repeated SLO misses. It provides an incentive to balance reliability with other features. So this is one of the areas which also Gartner has highlighted in its hype cycle. You will see more and more instrumentation of error budgets in applications. Now we talk about a very interesting topic, infrastructure from code. not infrastructure as code. So what infrastructure as code is where you as a developer needs to explicitly define infrastructure resources in separate files, say within like CloudFormation Serverless Framework, YML, or CDK stack, right? And infrastructure from code, which is one of the contenders in the Gartner hype cycle, is a way of creating applications such as that at deploy time, your cloud provider inspects your application code and then automatically takes care of the provisioning, whatever underlying infrastructure your application code needs. And there has been like new tools in this space. So there are some of these tools which I have listed on the slide: Anchor, Shuttle, Model, Netric, Clotho. Infrastructure should, like the idea behind all this is like infrastructure should self-provision and it should not create any cognitive load on the developers. Application also requires portability. So if you adopt this infrastructure from code approach, applications become more portable across technologies and cloud providers. There are references and good reads, which I have also stick into the slide if you're interested. Obviously, this is a very new area. Let's see how this matures. Another area which Gartner has referred to in the hype cycle is monitoring as code. So as site reliability engineers, why should you focus on monitoring as code? Gartner added this monitoring as code as emerging practice in the hype cycle, as I mentioned, for monitoring and observability and site reliability engineering. MAC allows you to describe the desired monitoring as code. With monitoring as code, you get declarative configuration files that can be shared across team members, treating it as code, editing it, reviewing it, and versioning it. So if you see on the right-hand side, if you have to deploy monitoring tools or monitoring application, you have to do it on each team, and the adaptability needs to creates a huge cognitive load. Whereas as a code approach, this can be shared across teams and it saves you from wasting a lot of time trying to kind of redeploy these monitoring tools with same team and making them adaptable with different teams. So obviously, if you're interested in this topic, I think there are some more resources available on this. And we'll move on to the next topic, which is policy as code. Policy as code is not a new topic anymore. Many companies have tried to implement it. Policy as code refers to the practice of managing and implementing policy decisions through code, making them enforceable and verifiable in an environment. Why it is important? Because it's in the suite of everything as code, policy as code is a very, very important element. People rally around a common set of as code skills and reuse existing skills, including familiarity with CI/CD workflow. Tools like Scheduler Policy Language, CPL, Terraform, or AWS config rules lead the implementation of policy as code in various environments. There are many other tools. I've just referred some of these tools here. Process, aligning people via unified workflow, aligning development, security, and operations teams around a single unified workflow. Everything as code yields immediate results. Now, coming back to log monitoring and analysis. Obviously, why log monitoring and analysis is becoming challenging? Because obviously there's a lot of data. There is also a practical problem with this data. Lack of access to raw data prevents users from transforming the data to alternative ways to extract new insights or develop new use cases. A new or fresh approach to this is a data lake based approach on an idea of storing data in raw form and broadening data access to break down the silos and accelerate innovation. So there primarily are three, key approaches to this. The lakehouse approach. Platforms like Databricks and Snowflake use this type of architecture, combining the features of data warehouse and a data lake into a hybrid architecture. Data lake approach is the solution uses a template-based approach that automatically configures existing services to support data lake functionality such as tagging, sharing, transforming, assessing, governing data in a centralized repository. And cloud data platform approach is in this setup, a self-service data lake engine sits on the top of cloud-based data repository, delivering capabilities like data indexing, transformation, analytics, and visualization. So these are the key changes and the approaches of in which, log monitoring and analysis becomes more accessible to the users. Now, there are other, advancements happening in this space, starting from generative AI, with the ability to analyze vast amount of data and generate human-like responses. By analyzing historical log data and identifying patterns of malicious behavior, generative AI can help security teams develop more accurate and targeted detection rules, reducing the risk of false positive. Another area is automatic log generation in log analytics. With generative AI, represents a transformative leap in the efficiency and intelligence of a system monitoring by automatically generating synthetic log data. And log analytics experience a substantial enhancement through the utilization of NLP, natural language processing, for log interpretation. These are new areas of engagements for site reliability engineers, and it will also open up doors for site reliability engineers to create more innovative solutions in this space. Moving on, observability. So the growth of observability market from was predicted from $61 billion in 2019 to $105 billion in 2023. So it's a substantial investment from a cloud native perspective in this space. So what's happening in the observability landscape? And of course, on the right hand side, I have stick a lot of applications and tools in specific areas. But starting from 70% of new cloud native application monitoring will use open source instrumentation rather than vendor specific agents for improved interoperability. And this is a prediction done by Gartner. 70% of new cloud native applications will adopt open telemetry for as observability rather than vendor specific agents. There is another very interesting area developing bring your own storage backend to enable more flexible and efficient utilization of infrastructure, and insertion of LLMs to simplify the user experience and enhance both analytic and downstream automation. So if you're interested to kind of dig deeper into this space, there are many tools in number of areas, starting from incident management, CI/CD visibility, to log analytics, ML model monitoring, LLM ops, to like digital solutions for like digital experience solutions for monitoring and analytics. So there are many areas of engagement here. Um, I'll not talk about all of them, but let's move on. Another area which is very interesting and was reflected in Gartner's report was augmented FinOps. So how it is different from traditional FinOps? So traditional FinOps focuses on fostering the collaboration between engineering, finance, technology, business teams. It provides a foundational approach to managing cloud financials by often um, looking like managing cloud financials, but often lacks the depth needed to effective cost optimization. So augmented FinOps, what it offers is building on the traditional FinOps by infusing it with artificial intelligence and machine learning. These technologies enable autonomous and continuous optimization of data infrastructure, shifting from reactive cost management to proactive strategic planning. So there is a lot of scope in terms of predictive, analytics and cost prediction models and so on and so forth being integrated into the SRE space. Lastly, I'll talk about AI assistance. Site reliability engineers, why they should focus on AI assistance. Obviously, what is the offering here? Um, um, artificial intelligence infrastructure as code stands for a new approach to automate the generation of IAC templates, configurations, utilities, queries, and more using OpenAI's APIs. So the areas of engagement would be like generating IAC. For example, you can use it for generating infrastructure as code scripts or templates, generating configuration files. You can also use it to generate configuration files that can specify the settings and parameters of various application framework or tools. Generate policy as code, as we have talked about. You can use it to generate policy as code scripts and templates. Query builders, you can use it for generating queries or statements that can retrieve, manipulate data from various sources such as databases, APIs, and command line builders. You can use it to generate command line arguments or options. Lastly, we will talk about continuous resilience automation. This is again one of the areas highlighted at the hype cycle. Resilience is an ability to bounce back while preparing to get better in any endeavor. It's not a reset. So the concept here is, instead of attempting to build systems that can never fail, why not focus on designing and building a system that are capable of fast automated recovery when inevitable happens. So what it needs is visibility. So organizations which have achieved this level of visibility are able to immediately identify an issue and its blast radius and its solution. So obviously there are multiple stack of information which needs to be aggregated, consolidated, and provide useful visualization, automation, automating incident detection and response and recovery. Codified skills to resist the skill squeeze that our enterprises need solutions to codify these heritage skill sets. So basically, if you're a sysadmin from the past, you need to the organizations need to see how do they inherit the knowledge and the skill set which the sysadmins, for example, have, and try to codify these skills. Composable mindset. So thinking about composably, meaning thinking of applications as packaged business capabilities rather than discrete products used by separate teams. So obviously, it also alludes or integrates into the as a service model or platform engineering, or orchestrate the services, tools, and applications in some way so that the SREs would have a better chance for using these applications and tools in a unified way. So lastly, concluding my talk here, site reliability engineers, like SRE is what happens when you ask a software engineer to design operations team. And this is again, all the elements or all the components which we have talked about today is based on, what we see is upcoming in the future. And hopefully you will all join us for the SRE Summit this year for more insightful, knowledge about what is happening in this space. We have a lot of good speakers. Some of these speakers you've already heard in various other forums, but this is a very, very interesting mix of talks which we have brought forward this time. So hoping that you manage to subscribe and register for the SRE Summit, and you could join one of our chapters to share your insights, knowledge, and collaborate with us. Thank you for listening today. Hopefully you have a good day.